Get started. Okay, so hi everyone again. My name is Ashish, and this is my thesis, Keys to Success: A Policy Roadmap for the Fourth Industrial Revolution, supervised by James T. Hackett. So let's get right into the brief time that we have. What is the Fourth Industrial Revolution? So we'll unpack that in my thesis, but I want to run through the methodology really quickly. So the question that I'm trying to answer is, how can we produce the maximum amount of economic output during the Fourth Industrial Revolution using policy? And the way I do that is through, number one, a synthesis review of existing literature, so secondary data, as well as literature on innovation and innovation clusters, and then case studies, both on, again, individual companies, and then case studies on industries as well. The contribution to scholarly research is very simple. It's be the first and most unique iteration of research to examine the policy environment of an entire industrial era, and then prescribe a recommendation set for policymakers. So the Fourth Industrial Revolution is a term that was coined by Klaus Schwab in 2015. He was the founder of the World Economic Forum, and he said that this revolution was unique for the three unique characteristics. Number one, the velocity of the innovation in the era, the breadth and depth, number two, and then the system's impact. It's easiest to understand what it is in terms of a simple example. So the Second Industrial Revolution, imagine a robot. During the Second Industrial Revolution, that robot would still need human intervention, but that human intervention was no longer manual. So the robot would be able to pick up a box from the conveyor belt, or screw a nut, or put a bolt in, etc. And the third, that robot is now programmable, but human intervention is still required to program it per function. So it's limited to picking up that box or screwing in that bolt, but it can do it without human labor. In the fourth, the only human intervention that will be required is programming that robot. And that robot will learn how to do the task on its own, which is why we define the Fourth Industrial Revolution as all technologies that effectuate the replacement of mental labor. This is a huge shift, and so the question arises, how can we ensure that the United States remains the leader in innovative and economic output in this Fourth Industrial Revolution amongst these technologies? Obviously, since we're taking a policy lens and crossing it with innovation and entrepreneurship, there's a lot of policy to get through, and plenty of policy buckets to sit and sort through. We identified 13 main ones here, based on using existing federal agencies as a proxy. And according to innovative relevance and materiality to innovation, we consolidated those into these 5 primary analytical categories. So commerce, science and technology, fiscal and financial, education and immigration were deemed the most material and were the subject of this thesis study. So going back into the Third Industrial Revolution requires using a policy framework. And so we used a very simple 5-point framework to analyze the effect of regulation on innovation, all the way up from a 1-point scale of prohibiting innovation completely with that statute or that piece of regulation, up to a 5, which is mandating it. So let's get right into the results. We deemed that the top 3 most material levers for innovative output during the Third Industrial Revolution, and again, this is 1960s to 2010, were number 1, science and technology. So science and technology policy has to do with the way government allocates R&D, research and development spending in particular, and then controls the licensing of that spending in relation to innovative research activities. What we found is that post-World War II, as the space race kicked off, the government embarked on a funding program for science and technology that had never been embarked on before. So investments in transistors and klystrons, again in radio. And so the government acted as a lead buyer of these technologies for new industries in Silicon Valley. So examples are like Huggins or Varians, and HP out in the Bay. And so the government filled this key role at a time when these technologies were not easily, there was no commercial market for these technologies. Early on, there's not an easy way to sort of market a transistor. And so the government filled a key gap until these commercial markets emerged in the 1960s. And again, that was a result partially of an accident, but during the 60s, McNamara, who was the DoD secretary, radically pulled back on procurement, and so that forced all of these industries to commercialize. And so we see how initial government support can be converted into commercial success later on. The second big lever was fiscal and financial policy. So a big innovation in fiscal and financial policy was the freeing up of capital and returning it to investors. We see that most prominently in the ERISA Act restrictions that were released in the 70s, which allowed pension funds to be invested in more riskier asset classes. So for the first time in history, pension funds were able to be used to invest in startups. And so that's essentially how the VC industry got started. So you can thank that act for all the VC funding that we see today. In the interim, the government had stopgaps like the SBICs, but again, the key takeaway here is government returning capital to investors. And then the third material lever was commerce policy. And so this has to do with IP, antitrust, and trade regulation. And so we can see that an aggressive antitrust posture, as well as licensing agreements with universities, so the Bayh-Dole Act in 1980 allowed universities to license all of the patents they were sitting on, were immensely important to commercializing. So there are other innovation drivers too, which are not policy related. I'll touch on the most important one, which were non-competes. So in California, non-compete clauses have actually been a staple of their policy environment for a long time. Essentially, it protects bright employees who want to switch between companies from getting litigated against when they go to another firm. This promotes employee mobility, promotes business creation, so very important for any innovation cluster. We also see academic entrepreneurialism. So Frederick Terman at Stanford, his steeple strategy of building expertise in niche, specialized areas of academic research, and then having an ear to the ground of the industry around him to apply that research and commercialize it. So let's look forward. What can we expect in the fourth? The fourth is all about automation of mental labor again, but we're automating many functions. We're automating finance, we're automating mental labor again, we're automating the way we move and the way we exist in the world. And so that's going to have profound implications. These are 6 policy areas I recommend we keep an eye out for. Again, the government's role in R&D, the government as a consumer of this technology, our antitrust posture, how employees can move and start companies, how we, a real area of concern for the United States that we're struggling in is bringing high-skilled talent to this country, and that's something we can work on. And then establishing a digital operating infrastructure as well. So these are my 6 keys to success, and I look forward to taking your questions. Thank you. Round of innovation, but a definite blind spot was, well, once we have all that innovation, what do we do with it, right? And so that'd be the next step. That'd be like once we achieve this, then we can, also have the discussions around what's the best way to regulate it. And that's why this is so important to the fourth industrial revolution, because Klaus Schwab points out that what's different about the fourth is that we're setting standards for digital infrastructure across the world. So China is racing to set that standard in terms of AI, as are we. And in a way, this parallels the 1960s when we had the USSR as our adversary, and we were sort of an exogenous motivator for the country. In the same way, the fourth industrial revolution is all about standard setting. And so from the United States point of view, it's very important that we set the standards so that we have the ability to dictate what is ethical, say in a digital world, on a connected world, rather than maybe an adversary. Do you have a question?
Yeah, so one thing I didn't really hear you talk much about in regards to sort of technological advancement in our modern day is sort of the presence of crypto, blockchain, metaverse, which are all pretty known to be anti-government per se. How would you feel like the government's role could potentially be reduced as compared to, say, the third industrial revolution, where they were subsidizing a lot of science, R&D, finance, etc.?
So this is one of the things that I also wanted to touch on. When you're talking about key differences between the third and the fourth, the fact that our the fact that the nature of our country as an innovation center is just different than the 1950s. We no longer innovate in labs. Innovation is headed by private industry now, as opposed to government. And we see that in the funding. So when I talk about public R&D funding in the 80s, actually public R&D funding became the minority, and private R&D funding is now the majority of R&D funding in the country. And so private R&D funding has shown to have less spillover effects for society than public R&D funding. So when you're talking about technologies that are inherently decentralizing, like the fact that the government doesn't have a role, and in fact the purpose of those technologies doesn't have a role, means that it'll be more difficult to control the innovation inherently. And so that's a key policy challenge that the United States will have to work through, which is how do you contend with decentralized R&D funding, decentralized workforce, so we're digitally connected from everywhere. We no longer have to be in Silicon Valley, for example, anymore, like we did in the 50s, in order to facilitate the maximum amount of innovation. And so it's a central challenge. That's one of the big challenges we're going to face in the board.
Well, thank you so much. This was
Thank you very
fabulous.
much.